All right.
Okay, good.
Yep.
Okay. We're going to get started, folks. For those of you on Zoom, you will start to see slides when we get going. Until then, you can enjoy the screensaver. But welcome, everybody. Thank you for coming tonight. I'm Brooke Millian. I'm the watershed coordinator for the Clarks Fork Yellowstone Partnership. I'm also a rancher on the East Bench between Roberts and Red Lodge. Tonight we have, I'm pretty fortunate, we're going to go through a bunch of information. And that being said, there's a couple of things that I wanted to cover before we got started. First of all, we will have a board meeting on Monday, January 29th at 6 o'clock at the Roberts Fire Hall. It's open to the public. So please, if you're interested in the business side of what we do, think about coming by and stopping in. There is an attendance sheet at the back. I'll circulate that. I think a few of you missed it on the way in. But it helps with our funding. We need to know how many folks are here. So if you wouldn't mind signing in if you're here, and if you're on Zoom, if you could just send us a chat message, just I will get it. You're not sharing your information with everybody on the Zoom. Next, if you've got your cell phone, if you could turn them silent, that would be awesome. We would sure appreciate it. We do have a lot of information to cover, so if you could hold your questions till the end, we would sure appreciate it. There's just going to be a lot of information. Probably a lot of your questions will be answered as we cover it. And on Zoom, again, just send me a chat message if you have a question, and we'll get to those at the end. I'm going to do introductions, and then we'll get going with the presentation. First of all, if you could raise your hand. Joel Adams is a hydrogeologist and the North American Director for Mine Water Geotech Division of IPI Packers. Joel is also the chairman of the Clarks Fork Yellowstone Partnership, and he lives up in Red Lodge. Next is John Wheaton. John is a retired hydrogeologist and CFYP's technical/science advisor and the lead on our water quality sampling project. John lives outside Fromberg. And last but definitely not least is Logan Beck. Logan is the Clarks Fork Yellowstone Partnership's technical coordinator and a Red Lodge local. Logan has an engineering background and is in his second year of graduate school, working towards a master's degree in land resources and environmental sciences. So with that, John.
We're doing our own advance. Thanks, Brooke. And like she said, thanks for showing up and coming out, and thanks for coming on to Zoom, those that are on Zoom. Before I start, I want to point out that John Reitman is here, also a retired hydrogeologist, and you're going to see some of his research work show up in the slides later on. But thanks for coming, John. And he's also got some maps from his publications back on the table to look at. I'm still trying to find a place.
So you're presenting there. Here's a guide.
And are you advancing?
I can if you want me to, or you can. It's just the
folder. Yeah.
Okay. Sounds good. See if we can.
We made a coin toss about what order, who was going to talk about which one of these subjects, and we decided to go from old to young. So I'm going to start with some general overview stuff, big picture stuff. Joel is going to narrow it down to Willow Creek between Red Lodge and Roberts and the Alphabers, and then the youngster, the grad student, is going to zero in on Willow Creek and do some of his own stuff there.
So over here.
So this is your role.
Just space bar. Oh, hold on.
Small technical glitches, but no. Okay, here we go.
Yeah, so it's either forward arrow or space bar.
Is it arrows or
space buttons?
And so, big picture, we'll start global. This isn't really relevant to what we're talking about tonight. It's just a really cool image that I really like to share as often as I can. The USGS a few years ago put this image together. And we all know the Earth is 2/3 water, right? That's kind of how we think about it, even though the water is a veneer. And so if you took all the oceans and the ice and all the lakes and rivers, and in fact, if you took the atmospheric water and the water in us and the plants and put all that water, seriously, all the oceans and ice and everything together, and instead of a veneer around the earth, made a sphere out of it, that would be, oops, the first one, the big sphere here. Honestly, that's their calculation of all the water on the earth. Which is pretty amazing to me. It's 860 miles in diameter. That also means it's halfway to the International Space Station. No, it's a third. Yeah, it's yeah.
So International Space Station is about 250.
So a third of the way. Height. But if they then take that and take out the unusable water, the salt water and the ice caps, you get down to that. That's all the groundwater, all the lakes, all the rivers, the big lakes, the little lakes. At a point in time, not the water flowing through the rivers, but the water stored in the rivers. That's not America, that's global. That's a 180-mile sphere, 180 miles. That's all the available surface water. And if you take out the groundwater, that's all the lakes and the rivers, little worldwide. That's not in Montana, that's worldwide. It just amazes me to look at that scheme. If you take the veneer of water and make it into a volumetric sphere, a very efficient sphere. But zooming in a little farther, let's look at Montana. And I apologize, I never finished my art class. So you have to put up with my art. This is a mountain. And I'm going to look at the water cycle from the mountains out into the prairie. This is a geologic cross section, sort of. There's a lot of bedrock aquifers, and there's crystalline rocks in the mountains, which aren't going to show up on it. We're talking about the gravel, so the shallow aquifer, the alluvium, and the mountain. And we'll put some water into the water cycle with some rain and snow on the mountaintop. So we put some water into storage in the snow cap. That's going to come out, some of it, as runoff when the melt or the rain exceeds infiltration, and that'll form little streams. Some of that will also soak in through the fractures and the talus slopes, the gravels, the soils, and travel subsurface groundwater. And both of these will eventually reach down, consolidate. Oops, I moved a few too many. And form like Rock Creek, a stream, and fed both by groundwater supporting the alluvial aquifer, surface flow building up, so we have an actual stream. That water, the alluvial system, and the surface water are interacting with each other. The surface water is feeding the alluvium, and the alluvium in turn is feeding the aquifer, depending on the meanders of the river and changes in slope of the riverbed. That water is moving in and out at very different velocities and very different quantities, but they're interfacing with each other. The stream then flows out of our little water cycle chart. The groundwater flows out of the chart. So we have an input and an output, but there's a whole bunch more coming in and out. Irrigation diversions go out, but those aren't consumptive. About 40% of flood irrigation is used. The rest of it is either returned to surface flow or groundwater recharge that gets back into the system. So we have return. Your sprinklers are a lot more efficient. You get less return, some. And ditches statewide, the average is about 1 cubic foot per second of ditch leak. In the Billings area, maybe a half a cubic foot or less. John, you're frowning at me. You agree with that? Okay. That's coming from the Bureau's numbers. And a half a CFS of ditch leakage doesn't sound like very much per second, but there's 86,400 seconds in a day. So pretty soon that's a pretty big chunk. And there's a lot of miles of ditches. So it's a big chunk of recharge to aquifers that we live with now. Rain's coming in and well pumping is going out. Well pumping, again, a lot of that water in the shallow system, if it's pumped out, you use it in your house, most of that water returns back to the shallow aquifer system. So it's a cycle and it's being used, taken out, some of it's coming back in. If not in this watershed, then an adjacent one. Evaporation and transpiration take it completely out of the watershed. Oops. When this water is coming in faster than this water is going out, we're increasing the storage. If we increase the storage, the water levels are increasing, and that's pushing more water out into the stream, so we're putting more water into the stream. So all along here, there's changes in the storage, and that's reflected in water levels. More water comes out, then the water level goes down. And so over a year, we have a constant change in water levels. And so people are out measuring stream flow. This is the acoustic Doppler current profiler, measuring the stream flow there. Or measuring water levels. It's an electric sensor on a 300-foot tape, drop it down the well. When it beeps, you know the water level, record it in the book. You take the data and build hydrographs. And this is an ideal textbook type hydrograph for a shallow well, not here locally. The water year starts in October because that's when recharge, the theoretical recharge, starts with the first killing frost. Those willow trees and cottonwood trees stop pumping water out of the aquifer. And so the aquifer is getting more water in than what's going out. You get recharge. In the spring, moisture tops that up. Then when the growing season really kicks off, it pulls it back down. And then the next fall, it starts it over again. Paying attention to when it peaks and the general shape of it, if we move into Montana a little bit, we've got snow melt control here. And so we get less recharge in the fall, but we get a big kick during the snow melt and spring rains. And so we move that peak over. So what the shape of the hydrograph is, it's telling you a lot about how the system works, how much storage is in the system, and how that stored water is moving through. Stored water is the only management tool we have. And snowpack and lakes, natural lakes, are the only natural storage mechanisms, but we have very little control over those. Reservoirs like Cooney or irrigation, recharge can be done through a variety of mechanisms besides irrigation, but you can control and store the water and time when it moves through the system with the man-made storage. Just for curiosity and for fun, how fast is water moving through the system? Rain has a terminal velocity of drop of about 20 miles an hour. Evaporation, that's not how fast it goes from the liquid phase to the gaseous phase. That's how fast it moves out of the watershed. Streams, yeah, maybe 3 to 5 miles an hour. The Yellowstone flows about 3. The Rock Creek certainly has some 5 mile an hour and faster ripples, but it varies. Canals, 0.5 mile an hour, about a foot per second. 1,002. Groundwater, on the other hand, has a real tortuous path that it has to follow. And so it's more in the feet per day. This is a pretty high number, actually, for groundwater. I calculated that based on some really clean gravels. And pretty good porosity. But just to give you, streams at 3 to 5, 3 orders of magnitude slower as the groundwater. Cooney has velocity in it too. Its volume and the Willow Creek and Red Lodge Creek coming into it means that water turns over. You compare those numbers, calculate 124 days to refill to flush the system. And that would be on average 0.0008. You can swim upstream, it's not that fast, but it still has velocity, it's still moving through. But it is in in the shallow system, the alluvium and the stream, it's still the same water. It's still the water in the stream is moving into the gravels and the alluvium downstream somewhere it's moving out, and that's on the bottom too. And anything you do here, like pumping wells or recharging, is going to come back into the stream. How far affects how much. If we were on an island here in Joliet, there really wouldn't be an aquifer underneath us. Can you imagine this being the land surface, a stream channel at precipitation of 12 to 14 inches a year and potential evaporation of 35 to 40? There's only the occasional rainstorm that's going to get past the root zone and actually build some aquifer material. Our aquifer is dependent on having a stream filling it up. So the creek, Rock Creek in this case, leaks and eventually fills up the alluvial gravels to the point where there's an equilibrium as we keep filling up a little more. And the alluvium supports the stream recharges the alluvium, and depending on time of year and precipitation, there could be water moving both ways through that. That would be, say, 150 years ago, but we put in irrigation systems, and this is the type of water levels that we have now, and this is what we're accustomed to and we expect to find, is these artificially elevated water levels from recharge from alluvium or from irrigation. And if we pump those wells, we remove that water from storage. And if we pump them hard enough and bring them down far enough, we can intercept the water that was going from this recharge to the creek, or actually intercept it and pull it from the creeks into our pumping wells. So just a point on how the systems work and what we do affects those systems. And we can measure them and know how they're reacting and keep track of it. Really collecting the data is crucial. It's Joel's turn now.
Thanks, John. So I'm going to try to take some of just the basics of what John just explained and see how they play out in our world here. And I'm going to focus on the Rock Creek watershed. We had some slides with the numbers. I think it's about a 529 square mile area. The Clarks Fork Basin, Clarks Fork watershed is something closer to 2,100 square miles. So about 4 times the size. I'm going to start with 2 really good questions. I lose sleep over these. It's like, if you look at some of the older maps, what we call Clear Creek was originally called Alkali Creek. And so either some good realtor, smart realtor way back changed that name because it would be easier to sell real estate, or it wasn't all that interesting of a creek. But how did Dry Creek get its name? Have you ever seen Dry Creek go dry? No, and either somebody had a great sense of humor, or when they named it, it was dry part of the year. So these are the burning questions that I'm going to try to help answer today. John talked a lot about alluvial aquifers, glaciers, all the action coming from the mountains. Produce alluvial aquifers along the east and west Rosebud and along Rock Creek, and that's just the cyan blue there is just a show of the aquifers or the alluvial glacial sediments that we see. If we look from Roberts towards Red Lodge, we can see a number of natural drainages: Clear Creek, Rock Creek, the West Fork of Rock Creek, and Dry Creek and Willow Creek. So if we are rude to Roberts and we cut it off the map and cut the world like a piece of cake, we'll see that these veneers that John was talking about, we've got basically 3 different aquifer or gravel aquifer terraces, primarily the East Bench gravel terrace, the Rock Creek alluvium, and then the West bench gravel terrace. Those are left over from all the activity of glaciers in the past. Turns out that people in the late 1800s figured out that if they diverted water from those drainages, they could get it out on those nice flat terraces that are now a lot of agricultural farmland, hayland, grains, all that good stuff. And we've actually got a lot more of these light blue irrigation ditches. I think realtors like to call them seasonal streams when they're selling property. And we use those ditches to spread water all over those alluvial aquifers. Some of it goes over into the Clark Fork Basin, some goes across the Willow Creek divide, but most of it is artificially brought onto the aquifers. And the whole process that John was explaining, some of it's used for evaporation, transpiration, growing the crops. Some of it infiltrates down into the aquifers, and some of it flows out of the system. Now, this is a little more detailed from some of John Wrighton's work. On the left is basically all the irrigation ditches on the east and west benches. And I started counting at one point, and I think I stopped at 40 miles. There's a lot of miles of ditches out there. On the right-hand side, you can see what the land is actually irrigated. Currently, or in 2019, I believe, under irrigation on the east and west benches, the blue areas are the ones that are actively irrigated. The brownish, yellowish areas have been taken out of irrigation or were never irrigated. I think on the east bench, it tends to be never irrigated because it just wasn't practical to get water there. On the west bench, subdivisions came in, and we're starting to convert agricultural land to residential use. If you look at the subsurface hydrology, John was talking about hydrographs. This is at the Remington Ranch from 2000. They just monitored groundwater levels for a year, and you see from November to May, a little different than what John was talking about. We see a general decrease late April through July, a real sharp increase in water levels. In fact, we're seeing 19 feet of water level fluctuation. That's massive. It's a lot of water, and it's not filling up a bathtub. It's filling up a system that's in motion. So if you think about the flux of water that's moving through, it's pretty incredible. And then July through September stays pretty steady, and then it starts to drop off. So what's going on? Well, if you look at when irrigation starts and when the irrigation stops, that pretty much coincides with how the water level acts. Also, as part of John Wrighton's study, he monitored for 10 years the fluctuations of groundwater levels and a whole number of wells. And astoundingly, they repeat themselves very, very regularly. And in the areas where irrigation has stopped, such as Remington Ranch, they repeat themselves. And we haven't seen a decrease in those levels. So kind of tells us that the majority of the water that we're seeing in those, bringing those groundwater levels up, is ditch leakage, not actual irrigation recharge. So yes, it's related to irrigation, but it's actual ditch leakage is providing most of the water, driving those water level changes. One thing fun, if you get enough data, you can actually make a map of the water level. And on the west bench, the map of the water level is kind of like a topographic map. And interestingly, if you you can see these arrows, and the water tends to flow kind of like the fall line skiing, where if you throw a rock down a hill, it's going to take the basically 90 degrees to the topographic surface Where it comes off to the edge, you can see that it's going to be moving to the edge. And we see this really clearly. I like to call it the green line. This is up by the airport, by Red Lodge, and basically we've got water that's coming up in the gray. The gray is the aquifer, the black lines are wells, and those wells are what we use to tell us what the subsurface geology looks like. Basically, that's filling up, a bit of it spilling over, and that creates this amazing set of springs that could fall all the way down on the west edge. What's that mean with surface water? You see the groundwater moves up and down a lot. This is the average monthly stream flow measured at Rockvale from 1920 to 1990. And so we're seeing, this is actual measurements, okay, that's basically averaged over what we see in a month, so each month has a point. Seeing 100 CFS up to a little over 400, down in the, I'm going to say 50 in August, when irrigation diversions are probably the highest. The USGS has a lot of these gauging stations, but they also have a modeling tool called StreamStats, where based on all the characteristics of the drainage basin, the slope, the elevations, they can model what it would have looked like when there was no diversion, just if it was the watershed as nature put it there. So these data are measured. What I'm going to show now is model. Model is never right, but if it's pretty close to being right, it's pretty good. So what we see, interesting, but if we didn't have any storage going into Cooney Reservoir, into Glacier Lake, we weren't doing any irrigation diversions, we would see that Rock Creek would be a lot flashier. It would have lower lows in the winter time, higher highs in the summer. Kind of makes sense because we're not taking that water out of the system, and transitioning back to lower lows. So blue shaded area here is water that essentially is being taken out of the system compared to the human involvement. Human activity is taking out of the system, putting somewhere else. Some of that gets used again by the plants, goes away out of the system. Some of it's stored in our reservoirs and in the groundwater system. Probably the vast majority of it's being stored in our groundwater system. Same time, late season, all that groundwater that was brought into the system is working its way back into Rock Creek. So in the January, interesting how everything kind of coincides, right, with the irrigation season. January through March, we're seeing, an increase of water than what the model predicts. And then again, September through December, an increase again. Obviously, in the heavy irrigation and low water season, we're seeing, the model says we would have more water in the system. So you have to look at we've created a man-made, a man-altered hydrologic system. And yes, Alkalite Creek probably was not that nice of a creek in 1850. Dry Creek was probably dry in 1850. And now we've got all these things that we now enjoy. And not saying things are good or bad, this is just how it is. And looking forward, some of the conclusions that John put together: water within our watershed originates with precipitation. Stream and groundwater levels reflect water moving into and out of storage along the water cycle. Understanding the water cycle and changes in water levels allows us to better plan ahead for resources. Just some closing thoughts. Basically, the introduction of irrigation in the 1800s fundamentally changed the hydrology of Rock Creek and many others in this intermountain region. A significant volume of the water that's diverted for irrigation ends up as groundwater and shallow alluvial aquifers, creates sustained flows in streams such as Clear Creek, Dry Creek. A lot of wetlands that we see along the bottom of the benches. Probably weren't there, or certainly weren't as significant in the mid 1800s. Also, future land changes in land use and irrigation practices could again have a really measurable effect on the current hydrologic balance in the watershed. So again, not saying it's good or bad, it's just that we need to, it's good to understand how our system works so that when we are planning ahead, if someone came up with the idea, we're going to, if Chris got this amazing bunch of money and said we can put every ditch on the Rock Creek system in a pipe, and we would conserve so much water. Well, that would have effects that would surprise a lot of folks, because it seems like such a great idea. And that is the end of what I have to talk about. And we can move over to Logan. I'm going to let you get yourself set up. Yeah.
A slightly different slideshow on here. All right. So, building off, guys, my part of the presentation is on the effects of snowmaking on Red Lodge, effects of snowmaking from Red Lodge Mountain on the Willow Creek watershed. So I actually took this picture today. I don't know if you guys saw it, there's a lot of snowmaking going up there. These big old clouds. Reasoning for this, I live on Willow Creek, and I had a applied watershed hydrology course last semester, and we get some flooding here and there, not a ton. I was just mostly curious if it's getting better or worse, or from the snowmaking and changes of the snowmaking on Red Lodge Mountain. So I decided to dig into it. So let's slow down. So snowmaking. So what does it do? So there's a couple good benefits of it. It really increases the natural snowpack on Red Lodge Mountain, and that really acts as a reservoir, so it can help, irrigation and keep the water levels higher later in the summer. So that can be good for farming, irrigating, things like that. There's also some studies that have shown that artificial snow melts more slowly than natural snow. It's a little bit denser, smaller particle sizes. But I was curious, my two main questions are, how does this affect the timing of peak runoff? Does it make peak runoff on Willow Creek later in the season than it normally would? Does it make Willow Creek flashier? Does it make it less flashy? How do specific events, like there were some big improvements to Red Lodge Mountain in 1998. They put in a couple extra lifts. They put in huge snowmaking infrastructure. For a while, it was actually the second largest snowmaking infrastructure in the state, behind Big Sky. So I was just curious. All right, so this is pulled straight from stream stats, like Joel was talking about. This is the delineation of the Willow Creek boundary. This is Red Lodge Mountain down here. It starts at about 9,400 feet. It's about 50 square miles. It's about 20 feet frame. It really acts as a pretty good sort of petri dish for how snowmaking would affect any watershed, because it's fairly isolated, and Red Lodge or Willow Creek, Red Lodge Mountain really only has permission to pull water from the Willow Creek watershed and put it right back into the Willow Creek watershed through snow melt. Also, the water gauging station from USGS has a pretty long period of record. It's got continuous data since 1937. And also there's a little bit of a sister watershed, which is Red Lodge Creek, that also has a similar period from USGS gauging station dating back to 1937. They're a little bit different watersheds. I'll get into the details of that here. But it makes for some pretty interesting comparisons. One does have snowmaking, the other doesn't. Little more info on Willow Creek here. Here's sort of the mean monthly stream flow. So Joel was saying Rock Creek can get up to about 400 cubic feet per second on a monthly average. Willow Creek, quite a bit smaller in May and June, and tops out at about 28 cubic feet per second, 29. Red Lodge Creek, so this is the USGS stream stats delineated stream boundary. A little bit different. It's got a few more tributaries like Coal Creek going into it. It starts a little bit higher. It's got a little more higher acreage above timber line. It's got a little bit lower by percentage irrigation. Willow Creek was 17%. Red Lodge Creek is 6%, but by acreage, it's almost the same. It's just Red Lodge Creek is 2/3 larger. Yeah. So my approach was to, for those that I created an R tool that pulls all the USGS data straight into spreadsheets to manipulate the data. But I wanted to see every single year since 1937 what the date of the peak runoff was year to year, and see if that's going up or down compared to similar watersheds. And then after that, do the same thing with flashiness. I'll get into how I calculated flashiness a little later with the Richard Baker index. But just in general, a little quick overview. Flashiness is just how quickly the stream's flow goes up and down relating to, runoff events, things of that nature. So here's a typical hydrograph. This isn't the water here. This is just an annual, January 1st start. Willow Creek. This is a pretty typical one with the peak runoff occurring very, very rapidly. Quick rise, quick fall. You can see pretty distinctive features based on probably runoff events, rain events, precipitation events, things like that. So you can see in the spring here, it goes up pretty quickly from the winter, and then it really spikes quickly and then falls, and then as that irrigation and evapotranspiration kicks in, it really drops, and then you get that first killing freeze. It actually bumps back up a little bit in late fall. This is typical. Peaks about, this is a pretty usual peak around 300 CFS. Can get quite a bit higher than that though, as I'll show in a second here. Yeah. So just in general for this presentation, Red Lodge Creek is in red, Willow Creek is in blue. I have the numbers here, but these are the water gauging station numbers. So these are the two largest flooding events since 1937 on Red Lodge Creek and Willow Creek respectively. 2005 was the largest flooding event in Red Lodge Creek, it peaked about 2,800 CFS. 2011 was the largest flooding event for Willow Creek, and it peaked at about 1,600 CFS, which for Willow Creek is pretty large. And then also these 2 years were the second largest peak on record for the other stream. So 2005 was the second highest flow for Willow Creek. 2011 was the second highest flow for Red Lodge. All right. So this is for my peak flow analysis. This graph is a little bit confusing here, but these are dates corresponding to these lighter lines here, and then these are flow cubic feet per second corresponding to the darker lines here. Again, red and orange, Red Lodge Creek, blues. So these are decade averages. So this is starting in 1930. I was just trying to get a quick and dirty rundown, see if I can find if there's large patterns. And mostly what I'm seeing here is these tend to match up pretty well. So I'm getting the feeling that it's not super related to snowmaking in any way, shape, or form. But regardless, I'm seeing potentially maybe a little bit of drop in date. Nothing to be gained from there. So this is every single year, and this is Red Lodge Creek and Willow Creek. This is the date of max flow. starting in 1937 and present here. There really is no, I used a linear regression model and we found the R squared. There really is no significant correlation between, time and decreasing period. For the date of peak runoff remains fairly constant. And just, to dive into it a little bit deeper, here's flow, cubic feet per second, here's the year, here's date. So this is the date, this is the flow. Again, these are complicated graphs, but really what it's showing, and linear regression models seem to prove that there's no correlation between decrease in flow or date for peak runoff here. And we can see I broke it up by that 1998 cutoff when they did the renovations to Willow Creek. Flow actually decreased from 1937 to 1998. It was a little lower than present. But that is the case for both Red Lodge Creek and Willow Creek. So the flow 1937 to 1998 was a little lower than it is from 1998 to present. That is interesting. They both show the same pattern. Again, hard to pin it on snowmaking, but it leads me to believe, well, maybe they're a little bit flashier. So then I dug into that. So the Richards-Baker index is a pretty widely used measurement of flashiness for those that are interested. Here's the equation here, but it's pretty simple. It just maps the change today's flow minus yesterday's flow over total flow day to day. Sums all those together. So it's a number between 0 and 2, with 2 being the most flashy. Willow Creek sits there at a 0.1293. It's reasonably flashy, but not horribly flashy. This is a graph showing every single year for the period on record. These are year to year Richards-Baker's index. So some of the patterns you can gather here, blue is Willow Creek, red is Red Lodge Creek. Mostly year to year, they are related. So there's no, Willow Creek didn't take any dives from any snowmaking effects. It still seems to follow the same patterns as Red Lodge Creek. These two guys up here, those are that 2005 and 2011 kind of anomaly flooding events. There hasn't been any statistically significant differences using linear regression models over time for the Richards-Baker index. Interestingly, though, two of the flashiest 3 years on record have been since 2005. There's one kind of anomaly year back in the 70s here. Again, breaking it up by that 1998 cutoff. Still hard to gain too many differences. These scales for RVI are the same here. One interesting thing to note, but we don't have enough data yet to prove it, is potentially these are lower on the whole with some larger anomalies. So that'll be interesting to monitor in the future. We don't have any statistical proof of that pattern that will continue. But that's what it looks like at the moment. So conclusions. So far, the timing of peak runoff and flashiness really doesn't appear to be changing due to snowmaking, particularly down at Cooney Reservoir. I'll get to why that might be the case a little later on. A lot of you, I'm sure, can already guess. It might be a little bit higher up if you measure right below Red Lodge Mountain. But really the peak runoff since 1937 to present, especially in Willow Creek, is consistent. It's around June 4th, average year to year. And the flashiness seems pretty similar, lots of up and down years, but there's no trends towards higher or lower flashiness. So some discussion points. So why would this potentially be the case? that, well, like these guys were saying, the aquifer really acts as a pretty significant buffer from Red Lodge Mountain all the way down the watershed. And also different sources of pulling the water out, like development would have an equally as large impact on the watershed. Irrigation has an arguably equally large change on watershed. This is snowmaking, land use changes, forest management. They've been doing all those thinning projects up there, getting rid of backwater transpiration pumps, the groundwater in the mountains. Has most likely been going up a little bit because of that. So there's a lot of things affecting the watershed on Willow Creek. It's really hard to point to changes directly from. Yeah, definitely challenging to differentiate the causations of why things might be changing on Willow Creek. It's a little, good news. There's no egregious changes from some of the watershed. That's what I got. This is Winnie. I get a little too dark here, but let me go over here and see what's going on over there. Anyway, yep. So that's what I got.
Was it?
Yes, sir.
All right, so Logan, did you calculate the surface area that was under snowmaking versus the total surface area? I mean, when I look at that, they throw up snow on about 10 minutes.
Yeah.
Compared to the whole watershed area and just about 7,000 feet.
Right.
Let's call that. What percentage is it? Like 5%, 2%?
Yeah, it's not a lot. Percent of area above 6,000 feet is only 10.6%. I didn't calculate the area of the snowmaking runs
Right, so-
that they have. It changes year to year depending on how they have.
Right,
Yeah, but it's not a lot. It's probably like 2%, 0.5%.
Right, so I mean, that's the only stuff that can actually impact what you're doing with snowmaking, like I said, surface area and how fast it's gonna come out.
Yeah.
They have no snow, obviously they pack a lot more water right there, but if it's on 1 or 2% of the overall area, you're not.
Yeah.
You don't have
It'd be
a variable
interesting.
that's gonna drive.
That's why, and also the distance here is such a big factor.
Oh,
Like
right.
if you measured it, right? Like I was curious about this just because my house is pretty close to down here. So we can notice some differences, I would say, year to year, like when they turn on the pumps or something like that. But even us, I don't think we can. But if you measured it right at the base of the ski area, you'd really be able to pick something up.
Yeah, Willow
Yeah.
Creek right there. Sure.
Yeah. I also just wanted, once I got into it, I figured out pretty quick that I don't think snowmaking can have a super significant impact. So then I was just trying to see if flashiness was increasing over time due to various things, development included. Probably a bigger impact in Red Lodge Mountain is going to be like Willow Creek Golf Course since 1937. So.
Well, just an observation of where driving our ranch somewhere like I can remember at least 1961 or 2 when I fall out of it. I've never seen it go down.
Yeah.
In 60 years. First, now wasn't there before the ditches. So you need to talk to some people that were out there. But I know they built the Finns who homesteaded our ranch out there, built the sauna on the creek. The sauna stuff, and that was built in 1880.
When were the ditches put in? I can't remember. Irrigation ditches dug in, so it's like 1830s.
Well, some of that, that's really old. 1890s, now the water rights.
Some of the oldest water rights are 1880.
Yeah.
John?
If I had to guess, 86, maybe.
Yeah, some of the areas I never really knew when I was like that. But a couple of things. One thing that I noticed on Logan, and I wish I had collected more information, but right where it comes out of the mountains and onto the bench, it appears to be losing a lot of water to the aquifer. There's evidence for that. And I wish I had done more monitoring to check the stream flows, but see stream losses.
Like it's a little bit bigger at Palisades Campground and down.
Yeah,
like
Palisades, then go into the development facility. Where it pops out, and then down at Fox. But we did notice that there was loss of water, which I thought was kind of interesting.
I think I think you're right on the money. I think there is a fair bit.
Yeah, and so it was actually, some of that water goes in and recharges the west edge off.
Yeah, for sure. I
Which
think quite a
we
bit of
did.
it does.
Feed base flow to West Fork in the main stem. Yeah, so you'd have to actually take the main stem into account.
Yeah, they pull West Fork over into the Willow Creek watershed also.
Yeah, it gets confusing, but, oh, it's interesting. Couple of other things, what is they use for water supply? And big wells?
Those big trees right at the base of, you know, where the lower parking lot is,
Yeah.
right across from that, there's a big pump house, we were there.
Okay.
They have another. There's a reservoir, it's very tall. Right on the very top, that's where it all gets started.
Okay. Not maybe they haven't built.
I was curious that one year, I forgot what year it is that, but the pond up on the top, somebody left the pump on too long and it overflowed and eroded the bank and they lost like the entire pond down the Whole Creek watershed, which dumps into Red Lodge Creek. So like all that water, they just redirected from below the,
Yeah.
like a hole.
Well, I suppose, yeah, because it would way down, and the reservoir's right above the drift.
Yeah, yeah.
And so it is kind of right on that ridge line there, if you go down that side. Yeah, because it would go down that side.
And I believe it did when we lost it. So I was curious if I could pick that up, but I had gotten buffered out of the data too much for that to see down by Coon, so. Yes.
Do you think, one thing I've heard about, there is the clearing of ski runs and the lift areas, would have actually led to some small but maybe measurable increase in total amount of snowmaking units, simply by reducing intersection by the force pump. Because I think there's a lot of literature that speaks to the watershed yield management via forest management, you know, thinning, clear cutting, and there's a pretty significant increase in total yield, of snowpack in forest and the timing of it.
Yeah.
I kind of wondered what that might be.
I was curious about that also because they've been doing those thinning projects up there the last probably 8 years, more and more so. And now they've done like pretty significant amount around the base area. And I was also curious to see if that would result in increased flashiness also because there's less ground flow transpiration pumps. So that surface water just runs straight off instead of getting used up by those trees really also. Yeah, I couldn't see too much differences in there if I couldn't either. Yeah, I was really hoping for a higher water gauging station, but that's an interesting. I hadn't considered that it might increase snowpack by thinning the trees out. But.
Is that a really dumb, can I ask you a dumb question?
Oh, yes.
Well, so how much water can the mountain take? And who determines that?
I'm not entirely sure of the volume. I believe.
They have, right?
They have water ice. Yeah.
Mhm.
But yeah,
Mhm. So then if they wanted to do more, make more snow in the future, they have to get more. They have to get more.
The reason this year.
Huh?
This year.
Can they apply for For Willow Creek or what? Willow Creek?
I think they read it.
Yeah, they want to put some log making, or some snow making houses.
Yeah, if it's over there.
And that's, and they want to build a reservoir right in the basin, house that's left, then they come down. So.
Yeah. Years, you can have it.
Oh, that's fair.
Good stuff is looking at enhancing recharge and actually with too much water. Looking at using snow path, the way it's still on the ground.
Actually, that's for the John, for the Zoom folks, if they're still listening, but speak up a little.
Oh, yeah. Hey, we were gonna have a speaker that's closer to the microphone, repeat questions.
Oh, yeah. Sorry about that.
Very good questions.
Nothing else, Sue.
Nothing.
No,
How many people are?
there's four.
I got a quick question for Joel on your green line thing. I was working here, I was kind of did a little bit of research. Wanted to see if there was any pictures from before the irrigation had been developed on West Bench between Red Lodge and Roberts. I couldn't find anything, but it would be interesting to see if that was at a different level. You could tell with pictures if that green line had been, I would assume it should have been lower.
I don't think it would be. The green line is basically where
But that's
they move where that's rock and people get together, so it's built like so. I would say it was less green. Because probably less water.
Yeah, that's kind of, I was trying to think that you're right, at least.
Yeah.
Stop it, yeah. One question.
Question?
Anything else?
Good stuff.
I'm gonna throw the screen back to Brooke.
What would you have to do for it? This is a master's thesis, right?
No, this was just a one semester
This is just.
class project, so I didn't get too detailed into it. Yeah, it'd be definitely worth exploring a little more potentially, but yeah, I just, did the research recently and we all thought that would be interesting to some people, but yeah, it wasn't like a super involved research project for sure.
I can add a thing from our experience over the Stillwater watershed project. We've been measuring Butcher Creek near the mound. Butcher Creek is the next drainage west of Redland. And so it was the subject of some study, quite a lot of study in the 1990s as a non-point source pollution management project. Butcher Creek. You've seen the lower part of Rosebud and often wondered maybe why the lower Stillwater River below Cirque it's off color compared to what it is above. It's mostly related to Butcher Creek and the erosion of the softer sediments in that valley from excessive irrigation return flows because Butcher Creek is generally irrigated by a transmission diverter from East Rosebud that comes across. That's the ditch you can see when you climb up the properties. You'll notice there's an irrigation ditch way up there 5,000 feet. Well, that's that ditch, and it delivers water not only Butcher Creek, but some of it within the Red Lodge Creek. Basically.
Is that one of Roscoe?
Yeah, right, exactly. And there was a lot of streamflow measurements in the 1990s during this 8 or so year period of studies. I had a DHES at the time, the Stillwater Conservation District folks, and DNRC folks, And so we started measuring it on a monthly basis, for the last 3 water years. And I made some plots of our data versus their data. And it's probably now flowing in the peak, the summer months when you expect this irrigation occur. It's probably now about half of what it was in the 1990s. And, where in the 90s, it was typically running 30, 40 cubic feet per second. And now it's in the 20s. And I would puzzle, I don't have an exact answer why that occurs, though. Visiting with folks that live out there and part of the watershed, they just think it's not related to irrigation pattern. That much difference could be accounted for by consolidation of land ownership, where landowners that now own it don't rely entirely on the hay base thing that butcher trade. They have hay base, maybe elsewhere, but they don't have to irrigate extensively. And so we've really seen, even though that ditch infrastructure is still in play, and it's still diverting water, we've really seen a decrease in output and probably a corresponding decrease in suspended solids flow going into those Beck Creek stuff.
Suspended solids? You're measuring suspended solids.
Yeah.
They're measuring suspended solids.
They did. They actually calculated annual use. Yeah, we could. Yeah, I mostly just looked at flows. Haven't run lows, but
As someone who's been over there, it seems dirty. Maybe that. Maybe I just.
yeah, no, it's not like it's you get into the sediment availability issue, like it's possible. It is, but if you lower the flows, then the flow rates are the big driver of flows. It's an interesting observation, I think, that we've been able to for years.
So that's.
Yeah, I don't, I'd say between the.
They're moving down that creek.
In the last few years, that may be part of it, yeah.
You always tell, I didn't think the fence is moving here.
But you also have, more gated pipe, you have some sprinkler systems in the basement. So there's a lot of changes going on within the irrigation regime that driving changes in everything.
We didn't talk about land use changes tonight. If you take out an irrigated field and put in a subdivision, you remove that recharge and you've added little drinking straws. So you get a double whammy for recharge and not for storage. So it's a pretty complex question. I'd like to make a plug for data and long-term data. It's really hard to find funding to go measure water for stream flows. And it's really important to have long-term data, not just an occasional measurement. And John was talking just before we started, he was telling me about a project. I don't know if you want to talk about that. What was that website for that organization? Reasons to be cheerful.
It's the name of this website that was actually developed by this musician, David Byrne of Talking Heads. It's the guy that started it. You just Google Reasons to be Cheerful, and they talk about all these different things that are going good. There we get a lot of negative news, so it's just something a little more positive, and it's international, worldwide. So they've got all kinds of things, environmental, social, cultural, whatever. It covers everything. But the reason I even know about it is a freelance writer from Missoula contacted the Bureau, and they contacted me and about a project I've been working on since the 90s in northeast Montana, where the local conservation district has a water reservation for groundwater out of the Clear Lake aquifer. And it's actually negotiating with the U.S. Fish and Wildlife Service, the Fort Peck tribes, and everything. They were all part of it. So we've managed that. And then expanding irrigation bill out of that. And it's looking pretty good, you know, it started during the drought in the 80s. This was when they first started looking at that. And water levels were dropping like a rock. Everybody thought it was because of irrigation, but it was the drought. And so we continued to monitor that, and it actually is kind of looks like a good news thing so far. And it's getting cooperation with the tribes, the U.S. Fish and Wildlife Service. Previous to this water reservation, U.S. Fish and Wildlife Service checked to every application in the state. But the local district got this water reservation. There, the NRC sits on a technical board that oversees it. So, and so far, everyone's been agreeable on adding increasing development. It's you know, there's several wetlands. There's a lot of it's a major migratory area, a nesting area for waterfall. So there's a lot of environmental interests. The tribes are interested because they're right adjacent to it. The water, the downstream. So they're interested in their waterways. So anyway, it's just kind of a side kind of interest thing. It should be coming out in February. So we'll see.
And the reason for that is long-term data.
Yeah.
Measurements.
Oh, yeah. That's what I've been measuring since the early 1980s. Water levels. And Joe Donovan started. So we've been measuring it for a long time. Managed to keep it on a shoe speed. And then the one thing like that is, you know, we do have several wells out there on the east bench and west bench that could actually, I don't think anyone has been in several years now, but
So there's transducers on that?
some of them do, they're probably still working.
Yeah.
But I know it's something that could be,
Oh, we can, I think
could be considered at least.
with the massive increase. Now it's being,
Yeah.
wells being drilled, I think it's critical to do that.
But I mean, that's something that should be figure out a way to get that done.
Yeah.
I think we'll need help. Once we got up, it's seen us 15. Eventually, we'll keep this. But anyway, it's something to think about. And maybe do.
Any other questions, comments? Well, this was recorded tonight, so we'll have up on our website here in the next couple of days if you want to forward the link to anybody that didn't make it. Thank you all for coming tonight. We sure appreciate it. And again, if you have any questions, you can email any one of us. Thank you.
There's some snacks in the back.
Yes, coffee.
Thank you for the coffee. That's, see. It's right, if it's not, it's something.
Big stuff out of you, but.